Hi there everyone, it's Mr. Baker here with another physics video, and today we're going to be looking at insulation. Okay, so we're going to be looking at insulation today, and we're going to be answering this question: how can we compare insulators? So what is an insulator to start off with then? So an insulator is an object that doesn't transfer thermal energy through it very well. Sometimes we might describe it as an object that doesn't conduct heat very well. But really what we should be talking about is something that doesn't transfer any heat energy through. And I've got some examples of some different insulators. So I've got a down jacket here. Now a down jacket is filled with feathers, and those feathers can be squashed together, but they've got lots of air in between them, and that's why they can be squashed together. So there's lots of air inside a down jacket. Now a down jacket keeps us from getting cold because there's lots of air. It doesn't conduct heat through it very well, and so it keeps us warm. A foil blanket might be used when you've maybe run a marathon or something like that. At the end you might see people wrapped up in these foil blankets, and what happens is that the heat that the body is producing is reflected back. The infrared radiation is reflected back into the body and keeps the person warm. So they're a really sort of light thing that can just be wrapped around somebody really quickly and to keep them warm. So it's slightly different to, say, a down jacket. The down jacket might stop conduction because of all the air gaps, whereas a foil blanket would stop the infrared from being transferred to the surroundings because it would reflect back into the object or into the person. Now, a vacuum flask is basically really good at stopping all types of thermal energy transfer. Vacuums haven't got any particles, and we need to have particles for conduction and convection currents to happen. So that can't happen because of the vacuum, and they are also silvered on the inside as well, so that means that all of the infrared radiation will sort of reflect back into the hot drink and keep it hot. It also works in reverse, that the heat can't get in either, and so if you've got a cool drink, you might want to keep it in a thermos flask to keep it cool for longer, because the vacuum will stop the conduction and convection from getting into the drink, any of the heat getting into it, and the silver will do the same by stopping the heat from getting into the drink as well. So similar to a down jacket, I suppose, is a cozy for a teapot, and so this is made of wool normally, and wool has lots of air gaps in between, and so the air stops conduction from happening from the teapot, and it also stops convection. Convection currents are the movement of air or any fluid, and so because the pockets of air are so small in the trapped air in the cozy, then they can't move around. They can't cause a convection current, and so it also insulates the teapot, keeps it warm. And that's basically exactly how a woolly hat works, in exactly the same way as a tea cozy. And then I've got a pan here. Now a pan actually isn't an insulator, so it's not the pan that I'm looking at which is the insulator, because pan, obviously we want the heat to conduct through, but we're looking at the handle here. Now the handle here I think is probably a plastic handle, and the plastic handle, if the pan's that hot, if you had a metal handle, then the heat would conduct straight through to you. So because the pan has got a plastic handle, we can pick up the pan and put it down, because the plastic won't conduct the heat to the person's hand. So there's some examples of some different insulators, but we're really specifically looking at household insulation today. So how do we insulate a house? Here's my house, and so the first thing we're going to look at is loft insulation. So we're going to be looking at some different examples of some household insulation, describing them, and then explaining how they work. So loft insulation is put in your loft, maybe on top of sort of some boards or in between the rafters or something like that, and it's basically made of fiberglass. Now fiberglass is glass, and it's fibers of glass, so it's kind of like really thin sort of hair-like strands of glass that's sort of woven together. So it's really itchy, really sort of horrible stuff if you touch it, but it traps lots and lots of air inside it. And because it traps lots of air, then it means that any heat that gets up to the loft because of convection or anything else can't travel any further, because then convection currents can't travel through the loft insulation. Also stops conduction from happening. Sometimes the loft insulation might be silvered, And if it's silvered, then obviously that will also reflect the infrared back down into the house. So this is sort of a zoom in of what it looks like, and you can see it's kind of this big spongy layer, lots of trapped air in between all those sort of layers of the fiberglass there. That means that it's really good at stopping conduction and convection. Okay, so that's loft insulation. Also, we're looking at something that lots of houses have, is cavity wall insulation. Now, a cavity wall is basically, you can see here, two layers of bricks. So this is the outside wall, which would be made of two layers of bricks, and then in between that would be this foam-like material. And this foam-like material is very similar to that sort of loft insulation. Lots of little bubbles of air, basically, that means that if there were any damage to the wall, then the foam wouldn't allow the air to sort of move around inside this cavity, so convection currents wouldn't happen. But because there's all this trapped air as well, any heat energy that's getting to the inside wall, let's say the inside of the house is warmer than the outside of the house, but it would work backwards as well. If the inside of the house is warmer, then the heat would be conducting through the bricks, and then it wouldn't be able to conduct through the foam, and so that would also stop conduction. So it's there to stop conduction and convection, and then to keep us warmer. So windows, double glazed windows, or if you're really posh, triple glazed windows. Double glazed windows, they're basically two layers of glass, and then in between that is air, or sometimes, again, if you're really, really posh, some kind of gas, or maybe even a vacuum. And so when the heat energy from the inside of the house gets to the window, it would conduct through a really, really thin sheet of glass, and then normally just leave. It'd be radiated out into the surroundings, or to just sort of warm up the surrounding air. So because there's this thin layer of air, or maybe even a vacuum, in between the two layers of glass, then because it's such a thin layer, convection currents find it really difficult to set up, so that stops anything like that happening. But also it means that the conduction can't happen, because conduction doesn't really work very well in gases, and obviously can't happen at all in a vacuum. And if you're really posh, then you might have another layer of glass which basically just increases that and stops it happening even more. So that's double glazing. Now, draft excluders. Draft excluders are a nice cheap option. So you might have a draft excluder, which is basically a piece of material, sort of a snake-shaped bit of material, then stuffed with whatever, some kind of cushiony type material. And that's really to stop drafts, which are basically convection currents, taking the heat energy out of the house. And then carpets. Carpets do a very similar job. So carpets, if we look at a zoom in of a carpet, so this is quite a thick pile carpet here. You can see that there's lots of fibres which really good at trapping air inside them. So because there's all this trapped air, you can't conduct the heat from your foot, say, to the ground, and so it stops the heat energy from being lost through you or anything else that's in the house and being conducted away. So that's our different types of insulation we use in the house. You might also see that some radiators have got this sort of silver foil behind. And this foil, it's not like just normal sort of kitchen foil, it's slightly stronger stuff so that it doesn't corrode and things like that, but the foil basically will reflect the infrared radiation back into the house, and so it will keep the inside warmer. So here's a description of all of these different things that you might want to take some notes on or something like that. So loft insulation is a layer of insulating material that's either over or under the loft floor. Sometimes it's coated in foil, and it works. Convection currents cause warm air to rise to the top of the house, and the insulation, as I said, normally fiberglass, has trapped air which slows the conduction of heat through the ceiling into the loft, and then so it can't get to the outside. Cavity wall insulation is a layer of material between inner and outer walls, sometimes coated in foil again. There is trapped air in the foam placed in the cavity between the exterior walls. This stops convection currents occurring and slows conduction of heat from rooms to the outside. In double glazing, that's two panes of glass with air or a vacuum in between. The trapped air or the vacuum are good insulators, and so will slow conduction of heat from the rooms through the windows to the outside air, because the layer of air is thin, and then it also stops transfer by convection. Now, draft excluders or door seals or window seals, it's a piece of material filled with foam or similar placed into the bottom of doors or around them, and they reduce convection or heat from the rooms to the outside. Carpet, a thick woven fabric placed on the floor, and it works by having trapped air in the fibres, which slows conduction of heat into the floor and then away. And then foil behind the radiators is a layer of reflective material on the walls behind the radiators, which reduces the rate of heat loss by radiation from radiators towards the wall by reflecting radiation back into the room. Right, so how do we compare different insulators? So there's a couple of different ways. We can either use U values or payback time. So U values compare the rate at which the heat is transferred through the insulator. And basically it's just the wrong way around. The lower the U value, the better the insulator. So the lower the U value, because that's the rate at which the heat energy is transferred through. So we don't want that to be high. So the lower that happens, then the better the insulator is. In payback time, it's a measure of the cost effectiveness basically. And payback time, to work it out, you look at the insulation cost. So how much did it cost for you to have your double glazing or whatever installed, divide by the annual savings that you make on your heating bills. And again, the smaller the payback time, the more cost effective your insulator is. So let's have a look at an example of that then. So how would I know which one I wanted to put in first? Would I want to put in carpet in my house, or would I want to put in double glazing? So let's say that the cost of carpet of your house is £500 and the cost of double glazing is £3,000. So the annual savings for if you installed carpet would be £42 on your heating bills. And the annual savings if you install double glazing is £300 on your heating bills each year. So which insulator would you recommend the homeowner installs first? And you need to explain why. So let's use payback time. So the payback time is the cost of insulation divided by the annual saving. So the payback time for the carpet, so it costs £500 and the annual saving is £42. And for the double glazing, the cost is £3,000 and we save £300 every year. So that means that the payback time for the carpet is 11.9 years and the payback time of the double glazing is 10 years. So because the payback time of installing the double glazing is less than the payback time for installing the carpet, you might recommend the homeowner put in double glazing. So this is what you should be able to do by the end of the lesson. You should be able to give examples of household insulators, explain how household insulators reduce the transfer of heat, and compare the effectiveness of different household insulators. So how do we compare insulators? That was the question we started with. Well, there's two ways really. We can use U values, which is looking at the rate at which heat is transferred through them, and the lower the U value, the better the insulator. And then we can look at the payback time, which is looking at the cost effectiveness, and that's looking at the insulation cost divided by how much money you save every year. And the smaller the payback time, the more cost effective the insulator is. Okay, so that's been all about insulation. I've been Mr. Baker, and I will see you next time.